In this video, I'm going to be going over the first 8 problems from the review. The first thing you're asked to do is to simplify the expression as much as possible and state the domain, okay? So here, for number 1, the expression is 3x squared minus 15x divided by x squared plus 3x. Okay, so we're going to simplify this expression. The numerator, you can see here, we factor out a 3x and we're left with x minus 5 divided by x times x plus 3. Now, there really are no, well, the common factor, actually, we mark out this x here in the numerator and this x in the denominator, okay? So when we do that, okay, when we mark those out, all right, we realize then that x cannot equal 0, all right? So x cannot equal 0. Then when we look at our final answer, okay, here in the denominator, x plus 3, well, we know here that x cannot equal -3. So when we state our domain, we have negative infinity up to -3, and then -3 to 0, and then from 0 to infinity, and this addresses the whole as well as the asymptote, okay? Number 2. Here we have 8x cubed divided by 16x squared minus 16x, and it is simplified. In the denominator, we factor out the 16x, and we're left with x minus 1. And finally, our answer, x squared divided by 2x minus 1, okay? What we factored out, the common factor, is an x here and an x here, okay? So that's why this 3 became a 2. Well, when we factored out those two x's in the numerator and denominator, we know that we cannot have that 0 in the denominator, so x cannot equal 0. And then in our simplified expression here, we have x minus 1, so we know that x cannot equal 1. X cannot equal 1. By the way, we could have written our final answer as x squared over 2x minus 2 as well, but in factored form, in this factored form, the denominator, we can see that the 1 would create the 0. So here again is your domain representing going from negative infinity to the 0 and 0 to the 1 that's not included, and 1 to infinity. All right, let's take a look at number 3. So we have factored this original expression. In the numerator, it's the difference of 2 squares. So we have x plus 2 times x minus 2. And then in the denominator, x squared plus 10x plus 16 factors out to x plus 8, x plus 2. And you can see that we can factor out the x plus 2 and the x plus 2. Well, then when we do that, we know that we cannot divide by 0. So in the bottom, we have a hole here where x equals 2, or I'm sorry, where x equals -2. So x cannot equal -2. And then, of course, in our denominator here as well, we cannot have a -8. So we know that x cannot equal -8 as well. Okay, so we represent that in our domain. Okay, number 4, we factor the numerator, x squared plus 7x, to x times x plus 7. And then the denominator, we have 2x squared. So when we simplify, we can cancel out that x and one of these x's in the denominator. That's why this exponent, or this x now has an exponent of 1, okay? So our simplified expression is x plus 7 over 2x. And what we do know, when we cancel out these two x's here, we know that x cannot equal 0, okay? Same really in the denominator. This is our asymptote. So technically, we would not necessarily have a hole because our asymptote, our vertical asymptote is x equals 0. But when we're just representing the domain, we know we can go from negative infinity to 0 and 0 to infinity. Okay, here in number 5, we're looking at 4x squared minus 20x divided by x squared minus 81. In the numerator, we can factor out a 4x, and we're left with x minus 5. In the denominator, we have the difference of two squares, x plus 9, x minus 9. So what we know in the denominator is that x cannot equal negative 9 because that would create a 0, and positive 9 as well. So we represent that in our domain. There were no common factors, but we cannot have a negative 9 or 9, so we represent our domain down here from negative infinity to negative 9 to positive 9, and 9 to positive infinity. By the way, we could just leave. What we realize is that this really can't be simplified, okay? But we write it with our factors here so that we can see what our zeros are, or our asymptotes. Okay, number 6. This one is actually multiplication. So the first thing I did was to simplify everything. The numerator in the first fraction, 9 times x plus 8. And then this trinomial here, we factored to x plus 8, x plus 2 times. And then we factored this trinomial to x plus 2 times x minus 9. And then it's divided by x minus 9. Well, we certainly see in our denominator, okay, that we're not going to be able to have a negative 8 or negative 2 or a 9, but we also recognize that we're canceling out the x plus 8 and the x plus 8, so we know there that x cannot equal negative 8. And we're factoring out x plus 2 and x plus 2, so we know that x cannot equal negative 2. And the x minus 9s cancel. And we know that x cannot equal positive 9, okay? And then, of course, when we simplify everything, we actually are just left with this 9 over 1, so that's just 9. But when we write our domain, we know that we can go from, oh, and it actually looks like my answer is missing part of it, because we should be able to go from negative infinity to negative 8. Then we go from negative 8 to negative 2, negative 2 to 9, and then 9 to infinity. All right, let's take a look at number 7. Okay, so this one's a little bit different. This is a division problem. And we know that when we're dividing by fractions that we actually multiply by the reciprocal. But the first thing that I did is I simplified everything, okay, beforehand, and I rewrote it. So we have 7x cubed over x plus 6 times x minus 5 divided by x times x minus 6 divided by x plus 6 times x minus 6. Okay, now, before we start, what we have is we have a fraction divided by another fraction. Well, each one of those represents a separate function. So this first fraction would be, say, f of x divided by g of x. Well, on its own, a function that is a rational function with a denominator, you cannot have any zeros. So we already know that negative 6 and 5 are not part of our domain because that would create the 0, the undefined, in the first fraction or the first function. And in the second function, before we even, multiply by the reciprocal, this function standing alone by itself, we cannot have a 0 in the denominator. So this x plus 6, the negative 6 would give us a 0, and the x minus 6, the positive 6 would give us a 0. So we already know negative 6, 5, and 6 are not part of our domain. Now, when we do multiply by the reciprocal, we have 7x thirds times x plus 6. Actually, you can see that we cancel out the x plus 6, or that would be just 1 over 1. So when we multiply now, we're just left with 7x cubed in the numerator. And then in the denominator, we just have x minus 5 times x. Okay? Well, we can simplify this some more because we can cancel out this x and one of these x cubed. That's why it becomes x squared in our answer. And then that, again, is our final simplified expression would be 7x squared over x minus 5. But we have to represent all of the domain correctly. And again, we did have this common factor of x plus 6, so we have the negative 6 that's not part of the domain. We also factored out the two x's, so x equals 0 is not part of the domain. But in the very original functions, we have to consider always that the denominator cannot be 0. So that's where this 5 came into play, and 6 came into play because this function cannot have a 6. So that's how you represent the entire domain for that one, for number 7. Okay, last one, number 8. This is multiplication. So you multiply the numerators, okay, and the denominator. I went ahead and factored first so we could see some of our common factors, okay. We do have the x minus 7 that we can factor out, or the common factor, I'm sorry, of x minus 7. We also have a common factor of x plus 8. All right. So we already know that negative 8 is not part of the domain. And we know that 7 is not part of the domain. All right. And then when we multiply, we just have x squared times x minus 4 divided by 4x. Now, here, when we continue to simplify, we do cancel out an x from this one, and then an x here. So that means x cannot equal 0. So we have to consider all of these. We have to consider the negative 8, the 7, and the 0 that would not be part of the domain. So negative infinity to negative 8, negative 8 to 0, 0 to 7, and 7 to infinity. Okay, and that's just the review of numbers 1 through 8.